Okay, we're on Unit 4, assignment number 5. These are the notes here. So the first thing the first part is, what does difference of squares mean? Here's what a difference of squares means. It means when an expression can be viewed as the difference of two perfect squares. Okay, so there's a couple things that have a difference of two squares that have to happen. Let me give you a few examples, first of all, of expressions that would be considered difference of two squares. I'll give you three. X squared minus 25, that is a difference of two squares. Let's use a different variable than x. Y squared minus 81, that would be considered a difference of two squares. Or how about 4w squared minus 36? Okay, so in order to have something that is considered a difference of two squares, you will notice that, first of all, there always has to be a subtraction symbol. If there's not a subtraction symbol, it's not a difference of two squares. That's what the word difference means. Difference means that you're going to have a subtraction symbol. Okay, and then the other thing is that both of the terms, a difference of two squares is going to have always two terms. The first term will always be a result of something multiplied with itself. So notice x times x is x squared. And the second term will always be the result of something multiplied with itself. 5 times 5 is 25. So that's what it means in the definition of it's an expression that can be viewed as the difference of two perfect squares. A perfect square like x squared and 25 is the result of some number or some variable being multiplied by itself. So if you look over here at y squared minus 81, y squared can be resulted by going y times y. 81 is the result of going 9 times 9. If we went to 4w squared minus 36, 4w squared is the result of multiplying 2w with itself. And 36 is the result of multiplying 6 with itself. Okay, now that's very important because if something is the difference of squares, this is what the general definition of difference of squares is. That means that it's always going to factor into quantity a plus b multiplied with quantity a minus b. Okay, so what does that tell me? Well, it tells me that if I have the difference of two squares, let's go with x squared minus 25, this will always factor into quantity x plus 5 multiplied with quantity x minus 5. Notice that the quantities have a plus and a minus in them, and they have a 5 and a 5 because 5 times 5 is 25. And they both of the quantities start with an x and an x because x times x is x squared. Okay, so the difference of squares is just a special kind of expression that if you recognize it, and if you know the pattern on how to factor it, you could actually factor without doing any work at all. So let's go ahead and let's take 4w squared minus 36. So that is a difference of two squares because 2w and 2w make 4w squared, and 6 times 6 makes 36. So that means this would factor into, without having to draw the area model in the diamond problem, 2w plus 6 multiplied with 2w minus 6. Okay, so that would be how to, what we have the difference of two squares. Okay, now let's go down, let's skip the what does a perfect square trinomial mean, and let's just go down to, whoops, sorry about that, let's go to factoring difference of squares here. Okay, So let's go ahead and go over that, how to factor difference of squares. We've already gone over it, and let's use the red one, the y squared minus 81 part. So this means that if you recognize something as a difference of two squares, notice y times y is y squared, 9 times 9 is 81, and we have a minus symbol. This means this is going to factor into, and you could factor a difference of two squares by just following the special pattern that the a squared minus b squared follows without having to do the area model and the diamond problem. You start with a y in each parentheses. One of them has a plus, the other one has a minus, and then it's y plus 9, y minus 9, because 9 times 9 is 81. This is a special type of expression. Only works for difference of two squares, okay? So if I had 25z squared minus 16, is that a difference of two squares? The answer is, of course it is, Mr. Trutna. 5z multiplied with itself is 25z squared, and 4 multiplied with itself is 16, and we have the subtraction symbol. So this means that 25z squared minus 16 would factor into, we start each quantity or parentheses with a 5z, we put a plus and a minus, and then we put 5z plus 4, 5z minus 4. It's a trick, it's a shortcut that you can use that only works in the special category of factoring difference of squares, okay? Now let's go to what does a perfect square trinomial mean? So you could see the definition is a perfect square trinomial is going to be a trinomial where the constant term's square root is, that should be is, 1/2 of the linear term's coefficient, okay? So a trinomial is when the constant's term's square root is 1/2 of the linear term's coefficient, okay? Let me give you the 2 examples of that so you can see what I mean by it. So you could go, that's a lot of words I don't understand. X squared plus 10x plus 25. That would fall under the category of a perfect square trinomial, okay? Another example, x squared plus 12x plus 36. That would fall under the category of a perfect square trinomial, okay? Next one, let me give you one more. X squared minus 14x plus 49. That would be an example of a perfect square trinomial. Now, it says it is going to be the constant term's square root. So remember, the constant term is the term in a trinomial or any expression that does not have the variable next to it. So in this case, the constant term's square roots are 25, 36, and 49. Now, when you take the square root of that constant's term, so notice the square root of 25 is equal to 5. If that is 1/2 of the coefficient for the linear term, which would be 10, then this would be considered a perfect square trinomial, okay? Watch over here. Take the constant term, 36. You take its square root, which is 6. Notice that the square root of 36 is 1/2 of 12. Okay, if this particular situation happens, this is called a perfect square trinomial. Okay, notice in the last one, the square root of 49 is equal to 7, and 7 is half of 14. Okay, now this can be extremely helpful in the world of math for the sole fact that if you are given a perfect square trinomial like x squared plus 10x plus 25, or the second one that I showed you was x squared plus 12x plus 36, or the third perfect square trinomial that I showed you was x squared minus 14x plus 49. Okay, these perfect square trinomials, and only these perfect square trinomials, can be factored without having to use the area model and the diamond problem. Here's how it works. X squared plus 10x plus 25, the perfect square trinomials always factor into a factor multiplied with itself. Okay, so they're always going to be a factor, they always factor into a factor to the second power. And what you put for the factors are the variable x plus, if the middle term, the linear term, is positive, and then the number you put is always half of the linear term, the middle term's number, which is going to be, in this case, 5. So x squared plus 10x plus 25 would factor into quantity x plus 5 to the second power. Moving over to the blue example, x squared plus 12x plus 36, that is a perfect square trinomial. That means it's going to factor into itself twice. And itself would be x. We always start off with the variable, which is x. Then we put a plus symbol. We always put the symbol that the middle term is. Okay, we're always looking at the middle term. And then we take half of that. Half of 12 is 6. So this perfect square trinomial would factor into quantity x plus 6 to the second power. Okay, x squared minus 14x plus 49 is a perfect square trinomial. If you happen to recognize that, you could write the factors without having to draw the area model and the diamond problem. Started off with x. Look at the middle term, which we call the linear term. It's a minus, so I put a minus there. And then I take half of 14, which is 7. So that would factor into x minus 7 squared. So you might be saying, Mr. Trutna, so I don't have to do the diamond problem or the area model any longer? The answer is no, Kimosavi. The answer is you don't have to do the diamond problem and the area model if you recognize an expression as the difference of squares and you know the pattern that they factor into, or if you recognize an expression as a perfect square trinomial and you know the pattern. If you don't remember these patterns, or if you just say, Mr. Trutna, that's a little too much, I don't want to remember the patterns, then by all means, draw the area model, draw the diamond problem, and factor them out. Now, the last example is we are going to find the area of this shape below, and we are going to find the perimeter of this shape below. And eventually, in order to do it, we're going to have to use the tangent function, the TAN function, okay? So first of all, let's go with perimeter first. So how do you find perimeter of a shape? Well, you add up all the sides. So you can see that bottom part is 18. The right side is 20. The left side is 26. And then you can see that there are two sides that do not know. I have the length of that side right there, which I highlighted in that purplish color. I do not know that. And I also have the length of this side right here, which I'm highlighting in blue. Okay, so in order to find the perimeter, I am going to have to add all the sides together. The problem is that I do not know 2 of the 5 sides. Okay, so to find perimeter, I'm going to go yellow side plus the blue side plus the green side plus the purple side or violet side plus the dark blue side. That, okay? I know the yellow side is 18. The blue side is 20. The green side is 26. I don't know the purple or the blue side. Okay, so there's a couple things that I could do here. Because this is what we call an irregular shape, an irregular shape is a shape that is not a normal shape, like a square or a rectangle or a triangle. What I want to do is I want to divide this into shapes that I understand and shapes that I recognize, okay? And in this case, the best idea is to draw a line going straight across there so that you basically divide this up into 2 shapes that you understand, and the 2 shapes being this rectangle and this triangle. Now, notice in the rectangle, I know that the entire bottom is 18, so that means the entire top is going to be 18. And notice that in the rectangle, the right side is 20, and this entire green part here is 26. So that means that if I move this 20 over here, that means 20 is from that bottom dot to that dot right there, which means that part right there has to be 6. Okay, so what I'm going to do is I'm going to take this triangle right here. I'm just going to redraw it out so that you guys can see what is going on. And this triangle actually turns out to be a right triangle. Okay, and that's going to be the 6, and that's going to be the 25 degrees. And then I'm going to then redraw this triangle again so that this 25-degree angle, which we call the slope angle, is going to be at the bottom left angle of my triangle. So all I'm doing is I'm just rotating this shape around so that the 25 degrees ends up down at the bottom left, and then the 6 ends up right here. And I'm going to find the value of x, which is that side. I need to know that because once I know how long x is, I could subtract that from 18, and then I'll know the purple side. Okay, and then I'm also going to find y, and y is actually right there, which is the blue side. Okay, so I'm going to find x first, and you can see when I rotate this triangle around to here, my x side becomes here, and once I find x, then I'm going to use Pythagorean theorem to find y. Okay, so first of all, let's find x. So my slope angle is 25 degrees. So that means my delta y over delta x fraction is going to be x over 6. Okay, now typically I need 2 fractions in order to solve this, and then I would cross multiply. But because I don't have a second triangle to compare this 25-degree triangle with, I'm going to have to incorporate the tangent function in this problem. So if you recall, you take the fraction delta y over delta x. You always want the slope angle to be there in the bottom left. And then we set it equal to the tangent of the slope angle, which is 25. Okay? Now, we use our calculator, and we figure out what is the decimal for the tan of 25. So you just type that into your calculator, tan 25, and you're going to get a really long decimal. And you're going to write the first 4 numbers after the decimal, which is 0.4663. And then we solve this equation for x. The way that we would solve it is we would multiply both sides of the equation by what's in the denominator, which is the 6. So we're going to multiply both sides by 6. On the left side of the equation, that the 6's would cancel each other out, leaving me with x is equal to, and then you multiply 6 times 0.4663, and that's equal to 2.79, or 2.8. Okay, so that means that's what x is, 2.8. So now watch. I now know x is 2.8. So I'm going to go up here to this triangle here. I'm going to change where the x was to 2.8. I'll write it in red. Then I'm going to go back to my picture, and where the x is, I'm going to change that to 2.8 as well, where the x was. I'll write it in red there. Okay, and then I'm going to, because the entire yellow part is 18, that means that this purple part is going to be 18 minus 2.8. So whatever 18 minus 2.8 is, that's going to be what my entire purple part is going to be. So you subtract those two. That would be 15.2. Okay? So your purple part is 15.2. I need that to find the perimeter. Okay? Now, all I need now is the blue part to find the perimeter. And I'm going to go back over here to this triangle here, and I'm going to use Pythagorean theorem to find the blue part, and I'll do it in blue. So I'm going to go 6 squared plus 2.8 squared. That's going to be equal to y squared. I'm doing a squared plus b squared equals c squared. I work this out. 6 squared plus 2.8 squared is 43.84. So squaring those and adding them, I get 43.84 is equal to y squared. And then remember, that means that your value of y is going to be the square root of 43.84. So use your calculator. You take the square root of 43.84, and that's a really long decimal. It's 6.621178143. I'm just going to say 6.6 for y. Okay, so that means now I'm going to, here's what I just found out. I just found out that my y, which is my blue side of this triangle, is 6.6. It's awesome. I just found that out. That means my blue part to help me find my perimeter is 6.6. So to find the perimeter now, I add up those 5 values. 18 plus 20 plus 26 plus 15.2 plus 6.6, 85.8. So my perimeter is going to be 85.8 for this irregular shape. Okay, now I need to find the area. All right, so to find the area now of the shape, what I have to do is my area is going to be the area of my rectangle plus the area of the triangle. So you're going to take the two shapes that are inside the shape, and you're going to find the area. Now, if you notice in the rectangle, the bottom part of the rectangle is the yellow. The right side is the blue. The yellow part has a length of 18. The blue part has a length of 20. And to find the area of a rectangle, you go base times height. So that would be 18 times 20, which is 360. So that's your area of your rectangle. Now I have to add that to the area of the triangle. Notice in the triangle, the bottom part is 2.8. The height of the triangle is 6. And to find the area of a triangle, you go the base, 2.8, times the height, which is 6, and then you cut that answer in half. In other words, you divide by 2. So you would go 2.8, multiply it with 6, get an answer, divide it by 2, and that is 8.4. Okay, and then to find the area, you would add up 360 with 8.4, and that is 368.4. Okay, there's a lot of good stuff going on in this example here. When you get to number 4 on your assignment number 5, please refer to this example. It'll help you out. That's all, folks, as SpongeBob says.